Alright, hello and welcome to the Lab 2 introduction video. By the way, this lab will not be due until week 7, so after the first midterm. So just keep that in mind. Before we look at the write-up, I would like to talk about the pair type in C++. It lives in the utility header, and what pair is a templated type. It takes two things. It's a type that holds those two things. So for example, if, I don't know, x holds 42, the int, and y holds like true, the bool, then if you say make pair, there's a function called make pair in the library that creates a pair of those two things. It just holds on to both at the same time. So that creates a p, and here's what p looks like. If you say make pair of x and y, p has a first thing, so you're trying to put them together, first thing and a second thing. And if x and y are these, then the first thing is, of course, the 42, and the second thing is the true. All right? And so the type of this now, because it's templated, p, the type of p, it's a pair of an int on the left as the first thing and a bool on the right as the second thing. All right? That's what pairs are all about. And you can say p.first to get out the 42 and p.second to get the true out. Okay? But you can just pass p around by itself as one big thing. It's just a pair. That's what it means. And let's see, go back to that page. And so here's the make pair function. Like, it takes a T1 and a T2 and makes you a pair of T1 and T2. It's very easily implemented. So here's a pair of two ints called foo, and it's a pair of int and int. Get the first thing, get the second thing. Pretty self-explanatory. It's just a way to pair things up, get them together. Okay, now we're ready for the write-up. Okay, so yeah, this lab. First of all, I want to tell you that you can work in pairs starting this lab. So not any more than two, groups of two only, but you are allowed to work in pairs for this lab and any future lab. I don't think I'm going to restrict that from now on. What I want you to do, though, when you work it as a pair of two, please submit separately to the autograder. Just submit the same code. It's easier for me to grade you that way. And also include a comment in your code saying who you worked with so that I don't get, like, worried when I see identical code. All right? See if you can find a pair partner if you're interested in one. All right, I can help you pass around your code efficiently between partners. If you have any questions about how to do that, I can help you. And then also, if you don't have a partner in mind right now, feel free to post on Discord to search for one. You are not required to have a partner, but you are allowed to have one from now on. Okay, so that is the start of this lab. And then here's the starter code. So get these files in the normal way, and then you're essentially going to be working in rsa.cpp. So this is you implementing the RSA encryption scheme. I have not told you how to do all of RSA, but a lot of the code right now you know how to write. All right, it's based on the things that we talked about today, or not today, but in the last lecture. Okay, so yeah, take a look at rsa.h. Your work is going to be implementing all the functions in rsa.cpp. All right, so all these functions. Some of them don't make sense right now because I haven't told you about how RSA works and what these numbers mean. But some of them do make enough sense. Like pal mod is supposed to return x to the power of y mod m. You could totally implement that right now. Just make sure to, when you have your loop multiplying x a bunch of times, make sure to always do mod m after each multiplication because x might get so big that it overflows the int type. Gotta watch out for that. All right, so that's my hint about pal mod. GCD, you know how to do. We talked about that in lecture. Extended GCD, we know how to do that. What extended GCD does is it takes two numbers and it finds those S and T's, or A and B here. It finds two numbers, a pair of numbers, right? A pair of ints such that x times the first number plus y times the second number is equal to that GCD. That's what it means to do the extended GCD. Find those coefficients so that you can make a linear combination of the original numbers that give you the GCD. And so you have to return a pair here. Makes enough sense, right? You have to return those two numbers that you could multiply by your x and y to give you that GCD. Okay? So it's very easy to confirm that what you're doing is correct. And then you also know how to compute the multiplicative inverse using extended GCD. So you're going to call extended GCD inside of the multiplicative inverse function. And instead of like x and y, I'm calling these e and phi, which makes sense in terms of RSA, but they're just variables. You're finding the multiplicative inverse of e mod phi. So you know how to do that in terms of extended GCD. Just get rid of the other thing. And yeah, the rest you'll have to wait on, but just come back here right after I talk about them in the next lecture, and it should be pretty quick. All right, so that's that. And then here's the .cpp file. So I don't think I gave you much help at all, but here are all the functions, and you will change these stubs, add the fix the fix-me's, and get things working. So GCD, pair, that is extended GCD returns that pair of two numbers, right? And then multiplicative inverse is the one I want to talk about. So the book should be good enough of a resource to implement everything except for extended GCD. So for that one, there's a Wikipedia page, all right? It has some pseudocode that you can copy. If you scroll down on this page of extended Euclidean algorithm, I think it's the first one. It's either the first one or the second one. Can't remember which. I think they both do the same thing. But let's pretend it's the first one. You are going to return, you're going to modify this pseudocode to return these Bézier coefficients. That's the coefficients in the extended GCD that you would like now. You'd like to make a pair of old S and old T, and that's what you return. All right, if you implement it this way. And it might be a little difficult to read this pseudocode. This is supposed to be the body of the function, all this, but it has something that you've never seen before called a parallel assignment. This exists in C++, it's just something I don't teach. What this is doing is it's setting two variables at the same time. So like old R and R is equal to A and B. So it's like setting A into old R, and it's setting B into R, but simultaneously, in parallel. And that is important when you're defining them in terms of their old values. So this is trying to set old R to R, the old R, and then setting R to this whole thing before we changed old R. Before we change old R and R, it's like compute this right-hand side with your current values, like get those two things, get those two answers, and then put them both at the same time into old R and R. All right? So you have to do all this first. Don't change anything, because like if you translate this to two lines, like R, old R equals R, and then R equals old R minus quotient times R, like you've changed things, and it's not the right answer anymore. So like compute these sides first, put them in like variables called A and B, and then put A into old R and B into R. All right, that's how you run a parallel assignment. So just watch out for that, and then your answer should be these things, old S and old T, by the time you're done with your while loop. That's how you implement the extended GCD. If you think about it long enough, it's essentially doing the stuff that we did on the slides, just a bit more efficiently, I guess, inside of a computer. Okay, so that's extended GCD. It needs to return the pair, and you have to order them properly. So it's like the first thing is the first part of the pair. That's the coefficient on the x, and then the second thing is the coefficient on the y. And then you can use multiplicative. You can use the extended GCD to implement your multiplicative inverse. Okay. You do have to watch out, though, because maybe the coefficient is a negative thing, and you're doing mod phi, so the only answers that you could possibly give back as the multiplicative inverse mod phi are between 0 and phi minus 1, all right? So you'll have to like add a multiple, add phi to this negative number to make it within the proper range if it happens to be negative. So just watch out for negative multiplicative inverses. They're not supposed to exist, because it's mod phi, and it should be between 0 and phi minus 1. So just watch out for that. The rest you'll know how to implement once I teach you RSA in the next lecture. But yeah, that's pretty much it. I've given you some testing functions that will test most of these things, test palmod, extended GCD, multiplicative inverse. Those are the ones you can kind of do right now, and then the rest are just RSA related. So get these tests passing, and that should make it work. All right, this is just making sure everything is as it should be. And yeah, they should make sense once you think about them long enough. All right, so please yell at me if you have any questions about that. But yeah, just compile, run the tests, get them passing completely after I teach you all of RSA, but I want you to get started early because you can implement these first three, palmod, extended GCD, multiplicative inverse. Sorry for the beeping in the background. But yeah, to turn in your assignment, just turn in that one file that you submitted, that rsa.cpp, and that's how you'll be scored. So yeah, get started on that. Once I talk about the rest of RSA, the rest of the implementation should make sense. But a lot of the functions you can do right now, so you might as well do them. All right, so that's your lab 2. Feel free to start checking on Discord, searching for a partner. You can use our CSCI 26 channel for that. So yeah, that is your lab 2, and I think that's all that I have to say. So I will see you next time.